Hello, everyone. I warmly welcome you to this presentation, where I would like to introduce the user story mapping technique. I will demonstrate what it is useful for, how it can help, and most importantly, I would like to find an answer to the question of how it facilitates shared understanding within a team or regarding a specific task. First and foremost, we will explore the concept of shared understanding, and then we will move on to the user story mapping technique itself. I would like to discuss what exactly it offers and where it can be applied. After that, I will share some useful advice and proven best practices related to this technique. Finally, we will summarize everything we have covered today. I would also like to introduce myself. My name is Kazmer Sarlis, and I am an IT professional. In addition to development, I had the opportunity in my previous workplace to focus on researching product development directions. It was of paramount importance to truly understand what the client specifically wanted, what the customer expected, and often the end user's needs, which might differ from those of the direct client, the one actually paying for the development. In many cases, the end user is the one who will use the application on a daily basis once it is completed. The user story mapping technique has been instrumental in helping developers gain a deeper understanding of what the end user truly needs. I have encountered numerous projects and developments where the final software did not fully meet the expectations of the end users. As a result, we cannot truly say that the outcome was a good piece of software, a good product, or even a good solution. The purpose of this tool is to bring the end user and the creator as close together as possible, essentially breaking down the tasks ahead based on end user goals. I would like to discuss what shared understanding is and why it is so important. I came across a great illustration that perfectly demonstrates this concept. Imagine ordering over the phone and saying you would like a 250 pizza, meaning two 50-centimeter pizzas. However, due to a misunderstanding, the world's largest pizza is baked instead. While the final result might be impressive, it is not what you actually wanted. And then, of course, the question arises, who will cover the difference in cost? Who will accept it? And ultimately, who will eat it? Another similar illustration presents shared understanding from different perspectives. It shows how a team builds a swing, but each stakeholder envisions it differently in their mind. This highlights how, without a common understanding, the final product may turn out very differently from what was actually needed. In the end, what is delivered is often not the same as what the client, or in some cases, the user originally wanted. At first glance, one might think that the issue lies in inadequate planning or insufficiently detailed task descriptions. While this is partially true, it is also very easy to fall into the trap of overdefining the task, attempting to specify every little detail, even aspects that perhaps, at that moment, we often still know very little. And this frequently leads to a situation where excessive requirements make a project rigid, preventing it from adapting to changing needs. If we follow this approach, our work often takes the form of what is known as a waterfall model. This model can be envisioned as a series of sequential processes. Planning and implementation stages follow one another, just like the cascading steps of a waterfall. Progress is linear. Moving forward is straightforward, but going backward is extremely difficult. If we think of construction as an analogy, the first step is the creation of an extremely detailed plan outlining every square meter and every brick's exact placement. Once these plans are completed, they are handed over to the contractor, who executes them precisely as they are laid out exactly in the plans. However, in this case, there is no real opportunity to make adjustments along the way. Once we see how large the kitchen actually turns out to be, or how much natural light the living room receives, it becomes extremely difficult to modify the plans and the process itself. Essentially, by starting the execution in this rigid manner, we are locking ourselves into a predetermined path. This is what I mean when I say that the process becomes overly rigid, leaving little room for adaptation. Of course, in the case of construction, legal regulations strictly define which documents are required before a project can begin. However, when we think about software development, the environment should be much more flexible and capable of adapting to changing requirements. In software development, It is common practice to follow an agile methodology where projects are developed in iterative cycles. Each of these cycles typically lasts 2 weeks, during which we aim to achieve a specific goal or fulfill a particular requirement of the project for the end user. At the end of each cycle, we present the results to the user, hand them over for review, and then continue improving the product based on their feedback. This could mean improving something, modifying it in a different way, or adding additional features. Experience has shown that this iterative, cyclical approach leads to the development of much higher quality software. It is crucial to base this process on shared understanding. If we look at the illustration where different stakeholders form their own mental images of what needs to be done based on the requirements, we can see that these mental representations often differ significantly. There's a great need for a way to validate and align these interpretations. Wouldn't it be ideal if everyone understood the same thing? If that were the case, we could be confident from a very beginning of the process that what is ultimately developed is exactly what everyone collectively agrees upon. If we look at this example, a great way to verify understanding would be to ask the participants to describe, write down, or even draw the image that is formed in their minds. By doing this, by having them present or reflect on what they initially imagined, we are already performing a kind of validation to ensure that we all understood the same thing. And today, with the user story mapping technique, our goal is to establish a tool, a structured process that, when applied, ensures that when we embark on a large project or the execution of a task, all participants share the same vision and have the same goal in mind. 2 decades ago, a programmer named Kent Beck realized, and his philosophy was that a good story, a small anecdote, could be more useful than a detailed documentation. When discussing a task, what he meant by story was that it helps uncover details that might not be included in the documentation, might be presented differently, or might not have seemed important at first, only to later turn out to be the most crucial aspect. He also famously said that a user story is not a document, but the beginning of a conversation. This initial conversation helps bring to light details that would otherwise be lost in an extensive and complex requirement specification. Today, we will take a closer look at these user stories, how they are structured, what they contain, and how they enable us to communicate in a common language with end users. It is important to note that user stories do not need to define every detail. Instead, these short narratives should serve as reminders of a longer conversation. At the beginning of the presentation, I mentioned the Agile methodology, which is based on an iterative work process and flexible implementation. One of its core principles is that collaboration with the customer is more important and should take precedence over the formal agreements, contracts, and written documentation between the client and the implementing team. Now, we turn our attention to the development of a user story map. The next key figure in this evolution is Jeff Patton, who took a significant step toward transforming user stories into a structured methodology. He established a system for organizing these small narratives and created the user story map framework. In the attached image, you can see a user story map. The specific content of each card is not important at this stage, but what matters is that they are arranged in a structured format. As you can observe, each card contains only a minimal amount of text, emphasizing clarity and simplicity. The most important aspect of the user story map is that it facilitates discussions. The meaning and placement of each card are thoroughly detailed in Jeff Patton's book, which is a highly recommended read for anyone who wants to explore this methodology in depth. It is an incredibly valuable resource. Now, let's examine the structure of a user story map. In this framework, the top row, represented by the orange cards, contains user activities and goals. This is a crucial point to remember. Directly beneath, in the next row, represented by the blue cards, we find the individual steps leading to these goals. These steps outline the user's journey, showing what actions they must take to accomplish the activities or achieve the goals defined in the orange cards above. A user story map is generally structured in a way that moves from left to right, representing the sequence of goals to be achieved over time. Similarly, moving from left to right, we can interpret these pathways or user journeys, which outline the steps a user must take to reach their goal. For example, if we imagine an e-commerce website, the first goal might be finding a product. Next, the user should be able to select the product and prepare it for purchase. Then, their goal would be to provide the necessary details for the transaction and complete the purchase. Finally, at the end of the journey, the user should be able to receive an invoice and have the package delivered. So, this represents the chronological sequence of events. These main milestones or key goals are defined at the top, and within each of them, we can break down the individual steps. For instance, if the goal is to find a product, the steps might begin with a search, then opening the product details page, followed by selecting the product, and so on. These top two rows form the backbone of a user story map. Below them, the yellow cards represent the individual user stories. These user stories break down each step in more detail, presenting specific scenarios, potential variations, and alternative solutions to different problems. As we build this map, we gain visibility into the actual scope of work ahead. It becomes a powerful tool for prioritizing tasks, helping us determine which steps are more critical and which are less urgent. Another crucial aspect of the user story map is that every story card is explicitly assigned to a specific step and goal, ensuring that everything remains structured and aligned with the user's journey. This structure provides an excellent reference point. If I randomly select a story card, for example, one of the yellow cards in the illustration, I can immediately determine its relevance by looking up to the backbone of the map. This allows me to see which user goal and which specific step it is associated with. Having this clarity is crucial because it ensures that for every task or feature, we can precisely identify why we are working on it. This helps prevent moments of uncertainty where we might question whether a given task is truly necessary, whether it has value, whether it contributes meaningfully to the user experience, and so on. We left off at the point where we established that the backbone of the user story map consists of user goals and activities, while the steps leading to these goals are mapped below them. To expand on this concept further, I have brought an example: car repair. A truly great service can be understood from the perspective of an average person. Imagine that one morning, your car has a problem, it won't start, or there's an unusual noise coming from the engine. The best car repair service, the one that stands out in the market, is the one that can fix the issue within a single day. If software is being developed for an auto repair shop, whether it is an online store or a management system, the most successful product will be the one that truly understands how important it is for the mechanic's customer to have their car repaired within a single day. This is their primary goal and the most important requirement of the service. Once we visualize this auto repair process, we can immediately begin to construct a user story map. In this case, on the top blue cards, I have illustrated the key sub-goals that define the essential steps of completing a same-day car repair. It begins with an efficient and rapid vehicle inspection to diagnose the issue as quickly as possible. After that, it is crucial that the procurement of spare parts runs smoothly so that no unnecessary delays occur in the process. Finally, the repair process itself must be executed in such an efficient manner that all these steps can be completed within a single working day, meaning not within 24 hours, but specifically within the working hours of a regular business day, from early morning until the afternoon. By structuring the process this way, we ensure that the developed software truly aligns with the actual priorities of those who will use it. If we have outlined these goals, the process of creating the structure can be carried out with the involvement of mechanics through consultations and interviews. Once these goals have been mapped out, we can then break them down into the specific steps beneath them, identifying what actions need to be taken in order to ensure that the vehicle inspection was carried out efficiently, what steps are necessary to make the procurement of spare parts seamless, and what is required to ensure that the repair process itself is conducted effectively. If we read through this from left to right, following the timeline in the user story map, we can see how the inspection process begins with receiving the vehicle, followed by compiling a fault list. Then, when it comes to procuring spare parts, the necessary components must be selected and ordered. After that, there is a waiting period while the ordered parts arrive, and the process continues with the efficient repair consists of inspection, repair, and handover. Once we have built a user story map, we can immediately apply the iterative work process mentioned earlier. We can take this plan to mechanics for validation, ensuring that it truly reflects their workflow and that we have accurately understood their daily routine. A mechanic can quickly point out whether the process is correctly structured. For instance, they might clarify that efficient repair actually begins with the repair itself, followed by the inspection, rather than the other way around. They can also highlight if we have missed an essential step, ensuring that the mapped process aligns with reality. In this example, we didn't even consider the billing process, even though it is obviously a crucial step in the mechanic's business. This highlights how the user story map helps us better understand how a mechanic works, how they think, and what steps they follow to complete a car repair. Reaching this level of understanding can already be considered a success, as it ensures that the process we are designing is aligned with real-world workflows. As the backbone of the user story map is now complete, we can start adding the user story cards beneath it. These cards break down the overall task into specific actionable items, defining what needs to be done. These user story cards follow a structured format. In the early days, they were written on paper slips or sticky notes, preferably with large, clear handwriting. This physical constraint played a crucial role in ensuring that the stories remained short and concise, rather than becoming lengthy documents or detailed requirements lists. The goal was to keep them as brief and to the point as possible, rather than using them as a space to record an exhaustive list of specifications. A user story follows a specific sentence template, where the structure of the sentence helps us define who is involved, from whose perspective the story is being told, what the goal is, and what direct benefit the user will receive when that goal is achieved. In English, the word order of sentences follows a different structure, which makes it easy to substitute the elements within the user story template. By following this structure, we can insert the actor, define the goal, and specify the result or the positive outcome that the actor will gain if the goal is successfully achieved. Additionally, on the back of a user story card or in an associated record, we can define the acceptance criteria, the conditions that must be met for us to consider the story as successfully completed. For example, in the case of the mechanic, we discussed a scenario where they identify a faulty part in the car and need to replace it. To do this, they must first order the correct replacement part. This simple user story could be structured in a way that clearly outlines the mechanic's role, their goal, and the expected outcome. However, identifying exactly which part is needed is not always straightforward. This is why, when developing an online store for car parts, it is essential to ensure that the mechanic can find the correct replacement with confidence. The system must offer parts in a way that leaves no doubt that the selected component is indeed the one required. In user story terms, this can be formulated as follows. As a mechanic working in an auto repair shop, I want to be able to find replacement parts that are fully compatible with the original so that I can be sure I'm selecting the right one, which allows to repair customers' cars at a lower cost. Thus, it will mean a competitive advantage over other repair shops in the market. We have now formulated user stories, such as the perspective of a mechanic specializing in older cars. In this case, the mechanic wants to find aftermarket replacement parts based on the part number of faulty, but still original manufacturer parts. The reason for this is to be able to offer more competitive pricing for their services. It is important to visualize this scenario and understand that the repair shop that can offer this functionality through its software will be more successful in the market. Likewise, the e-commerce platform that enables this type of search will be more valuable to mechanics. Here, we can also define an acceptance criterion, which is typically recorded on the back of a user story card or attached as an additional requirement. For example, the search engine must be able to return aftermarket parts when searching by the original part number. This requirement can only be considered fulfilled if, when entering a manufacturer's part number, the system also lists compatible aftermarket alternatives. And if we return to the first example of the user story map, we can see that the white cards represent these user stories. These cards break down the necessary small story fragments, which serve as reminders or references for what actually needs to be done. They help us recall what was discussed with the mechanics when we went through their workflow and requirements. Similarly, they capture what was mentioned by those involved in the auto parts e-commerce platform, ensuring that we keep track of what functionalities and features are truly needed. With these user stories, we can now fill up the story map. Over time, a large number of these stories are created, and in practice, they often end up covering entire office walls, where sticky notes are placed as a physical representation of the work to be done. In software tools designed for user story mapping, these digital cards fill up the entire screen and often extend far beyond it. This entire visual map provides a clear overview of the scope of work ahead. This visualization is especially useful when discussing priorities with a client or stakeholder. It makes it easier to draw a clear line on what should be included in the first phase of development. It is extremely useful in cases where we specifically need to draw a line with a client to determine what should be included in the first phase of development, or to explain why a program costs as much as it does, and what is behind it, the huge amount of work that needs to be completed. So, the way this appears and its visual impact generally has a very positive influence on these discussions. The user story map stuck on the wall should literally be imagined as different colored post-it notes with different short sentences or keywords written on them. And the entire development team discusses next to it what they will be working on in the next period or what the given project is about. And from here, they usually select which user stories they will attempt to implement in the next phase, in that 2-week period when they will actively work on something. We also mention mechanics here, which could be an independent repair shop or a specialized brand service center. In this story, one of the characters could be the car owner, and these personas are essentially representations of real people. They add a goal-oriented focus to the task and provide additional context, helping to differentiate between certain roles, goals, and subtasks. By associating personas with specific user stories, we immediately recognize that an independent mechanic works somewhat differently from a mechanic at a large brand service center. And this difference is not just in the work itself. The processes and individual steps also vary. A brand service center might have a much broader range of activities, with significantly more detailed procedures compared to an independent workshop. This is very useful because, with the help of persons, we can separate these differences within the story map. Similarly, the same person can have different assigned characteristics. For example, a customer who wants their car repaired within a single day may be willing to pay more, while another customer who is not in a hurry because the car is only their second vehicle and they use it as a hobby might prioritize cost over speed. For them, time is a much less critical factor, and they may be willing to wait longer if it means getting the cheapest possible solution. This makes them fundamentally different from another persona. Another key area where a user story map helps is in determining priority and task order. This prioritization should be understood as a step-by-step process. When we create a story map, the user story cards become the basis for the development team to carry out the tasks described on them. The team is able to estimate the size of each task, and based on this estimation, they can compare user story cards to determine how much can realistically be completed within a given time frame. At this point, it is very important that the client and even the end user can be involved in the process. Based on their feedback, or even in direct collaboration with them, we can determine which user stories should be implemented in the next iteration, meaning the upcoming 2-week cycle. Here, it is again extremely helpful that these user story cards are not just listed in an endless document, but are instead organized visually on a map. During the prioritization process, the user story card selected for the next cycle can always be placed in a way that maintains their context. This is especially useful when selecting user stories for each step in the process. For example, if we select one user story card for every blue card on the map, meaning we ensure that every necessary step is covered, then the user will be able to fully achieve their goal once these stories are implemented. This approach is incredibly helpful because it ensures that the chosen user stories are interconnected and that, by the end of the iteration, they deliver a usable and meaningful result for the end user. This visual representation is also extremely helpful when a client expects that all tasks will be completed within 2 weeks and questions why everything is not ready by then. Here, we can visually demonstrate that a large number of user story cards are already scheduled for implementation within a given time frame. If the client wants additional user stories to be included in the iteration, We can explain that for that to happen, other stories must be removed. Using the example from the diagram, we can point to the red-framed section, showing that this is the realistic amount of work that can be completed in the next iteration. If the client wants to add new stories, they need to replace some of the existing ones within that red-framed area. I have now touched on how prioritization and estimation work. In reality, user stories are not estimated based on time. We do not measure how long it will take to implement them. Instead, each user story card is assigned a story point value, which reflects the complexity of the task rather than the exact number of hours required. This estimation follows a special scale, using what is known as the Fibonacci sequence, where each number is the sum of the two preceding numbers. This helps categorize tasks in a way that accounts for the increasing uncertainty and difficulty as tasks grow larger. This effectively illustrates how each task is incrementally more complex than the previous one, which in turn is more complex than the one before it. It is a well-established method for determining, across 2-week iterations, measurable indicators that show how many story points worth of work the team can complete within a given time frame. If we imagine that our story cards have been estimated for their level of complexity, then this provides a certain degree of predictability regarding when all the cards or user stories on the story map will be completed, which, ultimately, is always the most important question for the client. When will be ready what they really want? In reality, this method can provide a fairly accurate estimate. The best way to create user stories is to do so together with the end user. In the auto repair example, this means working directly with a mechanic or even with a driver bringing their car in for repairs. We can create user stories through interviews with them, process their responses, and structure the insights accordingly. One of the great advantages of a user story mapping technique is that, so far, it has not involved any technical jargon at all. This makes it very easy to present both the user story cards, the goals, and the processes leading to them to the end user. So, if I were to show this user story map to a mechanic or to an employee at a web store selling car parts, they would all be able to understand it. They would clearly see the process flow and the logic of the cards, making it an accessible and intuitive approach for non-technical stakeholders. Likewise, from the other perspective, IT professionals who have never been exposed to the world of auto repair will also be able to understand what is represented on the user story map. This allows for the use of a common language, where every subprocess and detail is presented in a relatively simple and clear way. If we conduct interviews with different stakeholders, this is a well-established method for building an initial draft of the story map. It is essential, however, that we focus on open-ended questions rather than putting words in the user's mouth. We should avoid simple yes or no questions and instead let them tell their own story. For example, we can ask them to describe their last experience with a faulty car brought in for repair, or what happened when a repair did not get completed within a single day. If we listen to these narratives, we can create a high-quality user story map that captures the key goals necessary to ensure satisfaction for both the driver or car owner and the workshop owner. A great real-world example of a business that analyzes and develops its platform based on user story mapping is Barty Auto has. They recognize the problem and the importance of offering a major competitive advantage to auto repair shops. The ability to repair a car within a single day, even if the mechanic had no prior knowledge of the issue in the morning and still manages to complete the repair by the afternoon. Their service includes an advanced search engine that efficiently handles part numbers, including aftermarket parts, ensuring that mechanics can quickly find and order the correct replacements. Additionally, they provide same-day delivery, practically ensuring that ordered parts arrive immediately, further supporting the one-day repair process. And if we now look back at our first story map, where we outline the steps an auto repair shop must go through to repair a car, we can see how Barty Auto has software is well optimized for these exact points. It is no coincidence that they can charge higher prices for their products, as their service directly addresses the most critical user problem, which is speed. It is possible to find cheaper parts elsewhere, but in that case, the repair will not be completed within a single day. It will take much longer instead. Another real-world example is Forgax Semp Weber has, which analyze the steps that customers go through when renovating their bathroom or kitchen and searching for tiles. And the web store aims to assist customers at the most critical points in their purchasing journey. Often, these are very simple things, such as ensuring that each product has high-quality images from multiple angles and that it clearly states which showroom locations have the item on display. In this context, when customers find a product they like online, they often want to see it in person before making a final decision. One of the key considerations is that they should not have to visit multiple showrooms unnecessarily. Instead, they should be able to go directly to the location where the product is available for viewing. Similarly, the website also provides clear information on which customer service representative to call based on language preferences, ensuring that customers can easily get the help they need in their preferred language. The entire website experience or web store usage is much more convenient compared to many competitors. I would now like to talk about personal story mapping tools. What can be used to create story maps? As we have already mentioned, the simplest method is the offline approach, where short sentences are written on small post-it notes, and these are stuck onto a wall to visually organize the information. These are still widely used today, and they are particularly valuable because they encourage the team to work together, engaging in discussions about the tasks. These small notes help team members remember what the task is and what needs to be done. However, physical post-it notes are location-dependent, and certain tasks can be difficult to manage with this method. For example, adding missing elements to the story map requires rearranging and re-sticking the notes, which can be cumbersome. For this reason, very effective online tools are available to support user story mapping. One such tool is Stories Onboard, which provides strong support for user story mapping. Another widely used tool is Miro, which is free up to a certain size and allows various additional elements to be integrated into the planning process. These tools are collaborative, allowing multiple people to use them simultaneously, making them particularly well-suited for distributed teams working remotely. I would like to conclude the presentation by summarizing that user story mapping, which we have explored, is an extremely powerful tool for fostering shared understanding among all project participants. If for no other reason, this alone makes it worth trying to follow a project's entire life cycle using story mapping. This should not be thought of in the same way as a blueprint in building construction, where the plan is created at the beginning and remains a fixed, unchangeable document throughout the process. Instead, a user story map is a living plan which is continuously updated, expanded, refined, and kept up to date. At any given time, it visibly represents the task list for the next development cycle and can also include other related plans. It is also important to note that a user story map does not have to exist as a single document. Multiple story maps can be created to further break down complex subtasks or even to explore alternative solutions in more detail. I strongly encourage everyone to try it out and see its benefits firsthand. Thank you very much for your attention.